do is quadratic functions. Quadratic functions. Now, we're going to graph functions in the form y is equal to ax squared plus bx plus c, where you see here, you've got a, b, and c. Okay? You're going to find that the value of b affects the position of the axis of symmetry. Okay? Now, if we're looking at these pictures here, okay, we are going to kind of derive the formula for the axis of symmetry. So, looking at the first picture, we've got an A and we've got a B. So, here's our A, there's our B. Same thing with the others. The A is the first one, and the B is the second one. The coefficient of the second term. Okay? Now, notice that the axis of symmetry changes with each change in the B value. The equation of the axis of symmetry is related to the ratio of B over A. So if I take my B over A, up here it's going to be 2 over 2. This one is going to be 2 over 2. This one is going to be 4 over 2. This one is going to be 6 over 2, right? This one is going to be 1. This one is 2. And this one is 3. Now, I want us to take a look at where the axis of symmetry is, okay? The axis of symmetry is this blue dotted line, okay? So, this axis of symmetry is at x is equal to negative 1/2. Everybody see that? The second one, the axis of symmetry, is at x is equal to negative 1. And the third picture here, the axis of symmetry is at negative 1.5 or negative 3/2. So for each of one of those, the axis of symmetry is x is equal to negative 1/2, x is equal to negative 1, x is equal to negative 3/2. Okay? What can I do to each of these ratios? What can I do to each of these ratios to get me to my axis of symmetry? For each one of these, in order to get to the axis of symmetry, we're going to take that ratio, B over A, and then we're going to multiply it times a negative 1/2, right? We're going to multiply times a negative 1/2, which gives us our formula for the axis of symmetry. So the formula for the axis of symmetry is x is equal to a negative b over 2a. All right. So the graph of y is equal to ax squared plus bx plus c, where a is not equal to 0, has the line x is equal to negative b over 2a as the axis of symmetry. Now here's another little bit of information. The x-coordinate of the vertex is also given by that ratio. So this also gives you the x-coordinate for the vertex. If that's the x-coordinate, how do you think you're going to get the y? So you're just going to substitute that value of x back into your equation and then solve for y. And once you have the y, then you have the x comma y, which it gives you the vertex. Got it? All right. Excellent. So, problem 1 is graphing y is equal to ax squared plus bx plus c. Okay? When you substitute x equals 0 into an equation, y is equal to ax squared plus bx plus c, you get y equals c. Y equals c. When you substitute x into an equation as 0, you get the y-intercept. All right, so we want to know what is the graph of the function y is equal to negative x squared plus 4x minus 2. So the first step here is you want to find the axis of symmetry, and then once you get the axis of symmetry, find the rest of the coordinates for the vertex. Okay? So the axis of symmetry, we're going to use our formula. Symmetry. We're going to use the negative b over 2a. Okay? And we just get that information from our equation. So, the number in front of the first term and the number in front of the second term. This is the a, this is the b. So my a is what? Negative 1. And my b is 4. Okay? So now, we substitute in. So we've got negative 4 over 2 times a negative 1. And then we can simplify that to a negative 4 over negative 2, which gives us positive 2. Okay? That is your axis of symmetry. But it's also what? The x for the vertex. Very good. So this is also the x-coordinate for the vertex. Now we have the x for the vertex. In order to find the y for the vertex, what am I going to do? We're going to substitute that x back into the equation. Okay? So, let's see. Now we're going to find the y value. So we've got y is equal to negative 2 squared. Does everybody see I put parentheses here? So that exponent only goes to the squared, right? Or I could just keep the parentheses off. This is just to stress to you that it's only the 2 that gets squared. Okay? So negative 2 squared plus 4 times 2 minus 2. So this is going to be equal to a negative 4 plus 8 minus 2. So y is equal to, let's see, negative 4 plus 8 is 4. Minus 2 is 2. So there's my y value for my vertex. Okay? So, the vertex is at what coordinate?
2,
2, 2. Now the next thing we're going to do is we're going to find 2 other points on the graph. Okay? So we just make another function table. Alright. So we've got our x. What's our equation again? Negative x squared plus 4x minus 2. And then we'll solve for our y. Okay? about two easy ones? 0 and 1. Okay? Now, when we substitute the 0 in, we've got negative 0 squared plus 4 times 0 minus 2. Of course, 0 plus 0 minus 2 is going to give me negative 2. Right? By the way, when I put the 0 in for x and solve for y, what point does that give me? This is also the y-intercept. Very good. All right, so one more point. We've got a negative, negative 1 squared plus 4 times 1 minus 2. All right, so there is your two other points on your function table. All right, and step 3 is to graph. Okay, now the first thing I'm going to put on there is my vertex. Okay, so the vertex we said was 2, 2. Okay, so we're going to graph 2, 2. 2, 2. There is my vertex. Remember, at the vertex is my axis of symmetry. Now, looking at your equation, right here, is your parabola going to open up or down? It will open down. Why will it open down? It will open down because A is negative. Very good. All right. So, we know that our vertex is there and it's going to open downward. Okay? So, let's graph the other 2 points. So we've got 0, negative 2. 0, negative 2. And we've got 1, 1. 1, 1. Now, because we have the axis of symmetry, right, you know that it's going to be the exact same thing on the opposite side. Does that make sense? Okay? So, here, because 1, 1 is 1 unit away from the axis of symmetry on the left, we're going to have another one 1 unit away on the right. Okay? Since this one over here, 0, negative 2, is 2 units away from the axis of symmetry, then we're going to have another point on the right that's 2 units away from the axis of symmetry. Okay? And then you can draw your graph. And that's it. Problem 2 is using the vertical motion model. Okay? It says during halftime of a basketball game, a slingshot launches T-shirts at the crowd. A T-shirt is launched with an initial upward velocity of 64 feet per second. The T-shirt is caught at 35 feet above the court. How long will it take the T-shirt to reach its maximum height? And we also want to know what is the maximum height. And we want to know what is the range of the function that models the height of the T-shirt over time. The first step is to find your axis of symmetry, right? First step is to find your axis of symmetry. And we'll use our formula, negative b over 2a. Negative b over 2a. Now, from our equation, you can see what's our a and what's our b. is -16, and B is 64, okay? So we've got -64 over 2 times a -16. That gives us -64 over a -32, which gives us a positive 2. So now we want to find the vertex, more specifically the y value of the vertex. So we've got -16 times 2 squared plus 64 times 2 plus 5. All right, so the y value for our vertex is 69. So what is my vertex? X comma y is 2 comma 69. So here, 2 comma, there you go. There is your vertex. Okay? Now you have your vertex. The next step is to find 2 more points. Okay? So we make another function table. All right, let me write this equation down. All right, so let's choose 0 and 1 to put in here. So we've got -16 times 0 squared plus 64 times 0 plus 5. We also have -16 times 1 squared plus 64 times 1 plus 5. So this is 0 plus 0 plus 5, which is just 5. That's the y-intercept, right? All right, so there we have our other 2 points to put on our graph. Are there any questions so far? Pretty good? All right. So now we graph. So now we can graph, okay? Our vertex, we said, was at 2 comma 69. So let's see, this is 67. So 2 comma 69 is right there. Okay? When we graph the other 2 points, we have 0 comma 5. 0 comma 5. So the other point we have, Andrew. So the other point we have here is 1 comma 53. So there's 50. 53 is about right there. Now, we have our axis of symmetry right here. So that tells us that 1 unit away on the axis of symmetry we have on that side over there. And same thing 2 units away at 5. Okay? Now, that means that when we graph, this is our graph. So the first question was, how long will it take the t-shirt to reach its maximum height? Well, the maximum height is right here. There's your maximum height. And it took 2 seconds to get there. Okay? The second question was, what is the maximum height? Well, the maximum height was 69 feet. And finally, what is the range of the function that models the height of the t-shirt over time? So the range, because they are shooting out the t-shirt out of a cannon from 5 feet, your range values are only going to be from 5 to 69. So the range of the function is from 5, so y is less than or equal to 5, and y is also y is greater than or equal to 5, and y is less than or equal to 69. And there's your range values.